All right, so we're going to review finding perimeter and area for some of the shapes that we're kind of already familiar with, and then the rest of these notes will be working on kind of new formulas. But remember, perimeter, area are the same concepts you've probably been talking about for a long time now, right? Perimeter is the distance around a polygon. And remember, a polygon has to have straight edges, so we basically add up all the sides, and it's measured in plain old units because it's just a length, right? So it's going to be in feet, meters, centimeters, miles, but never squares. Area, however, is the space inside the polygon, which is measured in square units. So if you remember doing this back in like maybe elementary or middle school, you might have counted up the squares inside a shape and estimated the area. That's exactly what area is. It's how many squares of a specific side length will fit inside the shape. All right, so something to keep in mind, units will matter a lot because we need to make sure we understand the difference between perimeter and area and later on surface area volume. So you want to get used to writing down your units with every answer. If there's no unit given, so it doesn't tell you if it's meters or feet or miles, just use UN for units. That way you do have something labeled. Okay, so that's something to keep in mind. Some area formulas we probably already know. So rectangle, area is base times height. Parallelogram shares the same formula, area equals base times height. Square is a special parallelogram, also a rectangle, so area is also base times height, but because the base and the height are exactly the same, sometimes you'll see this written as s squared. Remember, base and height must always be perpendicular to each other. So when you're looking at a rectangle, this one's pretty straightforward, right? All four angles are right angles, so your two different side lengths are your base and your height. Right? So that could be, for example, base, and height. Parallelogram's a little bit different because parallelogram is tilted, right? So for example, something like that is a parallelogram. So how do we know the base and the height? Well, any one of the sides can be the base. So for example, if I call this top one the base, how do I create the height? The height's going to start at one of these corners, one of the endpoints of that base, and it's going to go straight down and make a right angle with the bottom, right? The parallel side. If you extended it to create a longer line, you'd see we make a right angle. I don't know if that's the best diagram, but that's what we're doing. We have to make a right angle. So maybe that'd be clear if I don't make that dotted. There we go. So for a parallelogram, it's still base and height, and again, the height is just going straight down. Okay? Square is a special parallelogram, special rectangle. So that one's also pretty straightforward. Every corner is a right angle. Every side is also exactly the same. So that's why even though you can label this base and height, you can also say, hey, that's s and s times s is s squared. Okay? So triangle, remember, is basically half a rectangle because we can put a diagonal there from one vertex to a non-adjacent vertex to create two triangles. So that's kind of the basis of the area formula for a triangle. So triangle is 1/2 base times height. And once again, for a triangle, which doesn't have to be a right triangle, the base and the height must always be perpendicular. So it doesn't matter which side is actually the base. So for example, I can say, hey, let's let this right side be the base. Then where would the height be? The height has to be perpendicular to that base starting from the opposite vertex. So I'm just basically going to be looking at this kind of segment there. So any one of your sides of a triangle could be a base, just like how any side of your rectangle could be the base. The height just must always be perpendicular to it, so you can imagine rotating it if you like having the base on the bottom. Finally, the circle. So circle isn't a polygon, right? Because it's round. Oh, that's really messy. So it's round, so we introduced that variable called pi. And you probably remember learning about pi. Pi is that kind of super long, not ending decimal value, 3.1415, blah, 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 going on forever. And we use that with our circle because it helps us calculate area, it helps us calculate circumference because we don't have these straight edges anymore. So you might remember the area formula for a circle is pi times radius squared, and pi is a number. So please remember, pi is not like a variable. I should say pi is actually not a variable, right? Pi is a set number. But so pi is not like a variable x, where x could be like 1, 5, 15, or whatever, depending on the problem. Pi is always set. So pi is a number. I should take that back. It's not a variable. Pi is a number. We can add, subtract, multiply, divide by pi. Use your pi button in your calculator. Please don't use 3.14. We want to use an exact value when we can. So we want to use the most exact format of pi that we can, which will be the pi button in your calculator if you're asked to round. Okay, if you're leaving your answer in terms of pi, then we'll just leave pi there. So circumference is the same idea as perimeter, but with the circle because it's the distance around the circle. So circumference is 2 pi times the radius, or circumference is pi times the diameter. Now, if you remember your parts of your circle, right, the circle has a center. The distance from the center to any point on the circumference is always the radius. You can do 2 times the radius to get the diameter. So that's the relationship between diameter and radius. Okay? And then once again, circumference is that distance around the circle. So it's basically the same idea as perimeter, but not called perimeter because a circle is not a polygon. So we have 2 review questions kind of reviewing these kind of more familiar shapes. So if you look at A, find the circumference of circle M. This stands for circle, this symbol. Find the circumference of circle M if the area is 225 x squared pi square feet. So just remember, the feet is only the unit. So please don't add that to your work. Some people actually put in feet squared, and it just kind of complicates everything because you look like you have a lot of variables. So what we want to do is we want to just use this 25x squared pi and find the circumference. And we're going to leave our answer in terms of pi. So what that means is leave pi in your answer. So you'll see I'm going to leave pi in my final answer. I'm not going to multiply by that pi button or the 3.14 or 15, etc. So how do we find the circumference given the area? So the first thing I like to do is I like to look at what I'm looking for, right? And then think, okay, what formulas could I use? Well, circumference, I know, equals 2 pi r, or pi times diameter. So I'm going to need to find out the radius, because the radius will also help me find the diameter, because I know diameter equals 2 times radius. So that gives me a focus that says, okay, cool. To find circumference, I just need radius. So they didn't tell me the radius, but they did tell me area. And I know area equals pi times radius squared. So what do you know? I can use the area that's given to me to find the radius. So basically substitute in 25x squared pi for area, and let's go ahead and solve for r. So we can see we can divide by pi because pi is a number. So we can add, subtract, multiply, divide, square root. We can do anything we want to pi. It's just an ugly number. And then we'll get 25x squared equals r squared. So I'm going to go ahead and square root that. So r equals, we're going to square root each of these separately. Square root of 25 is 5, square root of x squared is x, so the radius is 5x. So now to finish off circumference, circumference is 2 pi r, so that's 2 pi times 5x. Sorry, I wrote pi again, 5x. And then remember, we want to leave pi alone, so don't do 2 times pi. Just go ahead and put pi at the end with x. So we'll get 10 pi x, and don't forget your units. Circumference is plain old units. So 10 pi x feet is the circumference. Ooh, sorry, I just moved my paper. 10 pi x feet. Okay. The next one here, we're looking at a parallelogram. And once again, I start by looking at what am I trying to determine for this parallelogram? Area, perimeter, side length, what? So I'm looking for area of the parallelogram. So I know area equals base times height. So then I want to look at my diagram and say, okay, well, where is the base? Where is the height? Well, the right angle is the indicator we want to look for. So this right angle is showing me, hey, I have a pair of perpendicular sides right there. So since this top side also overlaps with the side of the parallelogram, the base is 11. So please don't add the 30 to it because the base is only that part of the parallelogram. We extended it out to make a right angle. So that right angle is just showing us where the height is. So please don't use the 30, okay? So now the question is, well, wait, I know area is base times height. Base is 11, but what's h? Well, think carefully about what you know about your parallelogram. So now we're not just plugging in numbers. We have to do a little critical thinking. We know, hey, wait, this is a parallelogram. Opposite sides are congruent. That's 34. I'm missing one side of this right triangle. What did we just review in the last unit to help us solve that? The Pythagorean Theorem, right? H squared plus 30 squared equals 34 squared. So if I solve that Pythagorean Theorem, I'm going to see h squared is 256, h is 16, and now I can find my area. So 11 times 16 gives me 176, And don't forget your units. Area is square units, so square millimeters. So those are just 2 examples using some familiar formulas. Please be aware, I could ask you to work backwards. I could say, hey, given the area is 176 square millimeters, what's the base of this parallelogram? Give you that diagram, right, and tell you height is 16 or something like that. So we should be able to solve for any variable, not just area, not just circumference, but you can solve for r, you can solve for h, you can solve for b. Okay?